Hello, let's begin our class. The course website updated the quiz results and assignment results, and you can take a look. For the quiz results, each week we will have 3 single choice questions, and each question is worth 25 points. And the attendance is also worth 25 points. So a total score is 100 points. If you have any issues about quiz results, please contact me as soon as possible. For the quiz, for the results of assignment 1, I will update the accuracy each week until the deadline. And here, accuracy means I will use, for example, 100 inputs to your program. And so your program will generate 100 outputs. Then I will count how many outputs are correct. And then I can compute the accuracy. And if your accuracy is 0, this means your program does not follow the assignment requirements. So you can carefully read the assignments. Your program output should be exactly the same as the given example, including spaces, line breaks, punctuation, and you can carefully read the code template. This code template specify the input and output formats. I saw some incorrect outputs. Some students delete this line. Some students delete this CL statements. This line is required. And I also see some students output additional line breaks. For example, some students output additional line breaks. Another mistake is to switch the sequence of statements. For example, I see some students switch C in and C out. The first two C in and C out statements, and this will cause the problem to the program to have different outputs. So if your accuracy is 0, then you can read the instruction below to check whether your programs meet the assignment requirements. And if your accuracy is greater than 0 but less than 100, then this means your program still has issues, and you are suggested to test all the input-output samples. For example, you can text this number 633, and you can check whether your program output matches the output samples here. And for our assignment, if you submit your assignment by 9 p.m. On Wednesday, then you can view your program's accuracy on Thursday. But if you submit it after 9 p.m., then you have to wait the accuracy update next week. Next, let's open the slides of chapter 2, C++ basics. Last week we already learned some fundamental terminologies about C++ programming, and we learned some built-in data types such as integers, floating points, and literals. And next, I will introduce integer and floating point division. First, let's talk about precedence. Precedence means suppose you have one expression, and this expression has more than two operators. For example, the plus and the multiply operation, and you need to determine which operation will be carried out first. According to the arithmetic rules, we know multiplication will be performed first. So the computer will first multiply y with z, and then and then perform the addition, x plus y times z. And this is known as the precedence rules. And if you want to change the precedence, you can use parentheses. For example, if you want to force the addition to perform first, then you can use parentheses to quote x plus y. And if you omit parentheses, the computer will follow the precedence rules to determine which operation will be carried out first. Later we will talk about this. And we can do some simple experiments. For this expression, we don't use any parentheses, so this will follow the precedence rules. So the multiplication will be carried out first. So 3 times 4 is 12, and 12 plus 2 is 14. And if we want to change the precedence, you can use parentheses. Now suppose we compute the addition first. You can use the parentheses. So 3 plus 2 is 5. 5 times 4 is 20. Oh, so this is the same as our arithmetic rules. Next, let's talk about integer and floating point division. Now, suppose we want to perform division. For example, 5 divided by 2, and then we will expect the result to be 2.5. And however, C++ outputs 2, not instead of 2.5. And this is because if both numerator and denominator are integers, then the division result will be also an integer. So the result is 2.5, and 2.5 will be converted to integer. And the 2.5, the digits after decimal points will be discarded. So the result will be 2. And this is known as integer division. So integer division generates integer results. And if we want floating point, then you need to use floating point division. To do this, you can convert the numerator to a floating point. So here I type 5.0, or you can omit 0. So the numerator will become a floating point. And this time, this division will be the floating point division. So you see the result will be 2.5. You can also convert the denominator to floating point. You will also have a floating point division. So either if you convert either the numerator or the denominator or both to floating point, then you will obtain floating point division. Next, let's see. Here is one identity. This identity is known as quotient remainder identity. For example, let's use one example. Consider integer 8. Then 8 can be written as 3 times 2 and plus 2. Here 3 is the divisor and 2 is the quotient, and the 2 is the remainder. And how do you compute the quotient? So here, how do you compute the quotient? You can use integer division. Here is one example. Look, you can obtain the quotient by perform the integer division. So 8 divided by 3. The integer division gives 2. So here quotient is 2. And we can use the modular operator to obtain the remainder. So here remainder is also 2. You can print its values. So here you can print the quotient and remainder. Actually, this formula can be applied to any integers. So you can change it to any integer. For example, 1, 2, 3, 4, 5. You can verify that this quotient remainder identity also is equal to its input. And this modular operator only applies to integer data type. So this operator cannot be used for floating point. So for here, you cannot use a floating point here. Here I add a decimal point. So this is a floating point. So here you will have a syntax error because this modular operator can only be applied to integer data types. And if you need to perform modular to floating points, you need to use f mode. This is defined in another library. This is defined in So if you need to compute the remainder of division for floating points, you can include a library in order to use this f mode function. Next, let's see another example. For example, if you want to compute a sequence of divisions, for example, 1 divided by 2 divided by 3.0, and we need to, and in this expression we have two divisions. The precedents are the same because they are the same operators, and we begin from the left operators. So we will compute 1 divided by 2 first, and because both numerator and denominator are integers, so this will perform integer division. So 0.5 we discard digits after decimal point, so we obtain 0, and then you perform the second division, 0 divided by 3.0, and this is floating point division. The result is 0. You can add a decimal point. Below are some common mistakes about integer divisions. Here is one example. For example, you want to compute price 1 and price 2. And price 1 and price 2 their expression are similar. The only difference is that when computing price 1, the denominator is 30.0, and for computing price 2, the denominator is an integer, 30. And if you run the code, you will find the value of price 1 is 1000, while price 2 is 900. So this gives you different results, although the expressions are very similar. This is because when you compute the value of this expression, and this is floating point division, while the second one is integer division. So the two divisions gives two different results. Next, I have one examples similar to this. For this example, suppose I initialize x to 10, and I want to perform this division, and we can expect the result is 3.333, or the result is integer 3. And do you know which result is correct, the first one or the second one? If you think the answer is the first one, please raise your hand if you think the result is first one. Okay, if you think the result is 3, please raise your hand. Okay. Let's see the results. The result should be the first one. The result should be first one. You see, because this is a floating point division, this is not integer division. So initially, you might replace x with 10, but actually, you need to look at the data type of this variable. This data type is a floating point, not an integer. So here, the computer will perform floating point division because the numerator is a floating point. Actually, when you write this statement, the integer 10 will be converted to floating point. So integer 10 will be converted to 10.0. Then 10.0 will be assigned to the double variable. So here, this division is floating point division, not integer division. Next we will have the quiz. We will have the quiz, and you can log in into the Rubio first. And if you cannot log in the Rubio, if you need an answer paper, please raise your hand. If you need answer paper. Anyone need an answer paper? For the quiz, you cannot use laptop. and tablet. So close your laptop and tablet until the quiz is over. The first question is given decimal number 6, and if we perform the left shift operation, and you need to compute the binary representation of this value. Uh, 30 seconds left for this question. Next, let's see the second question. In this question, I use unsigned integer 8. I use this data type to declare a variable pixel. And we have two statements. You need to determine the value of pixel after the two statements. 30 seconds left. Then let's see the final question. The final question is to determine which statement is illegal. For the option 3, we have 2 double quotes, and inside double quotes is nothing. For option 4, we have 3 continue backslashes inside a double quote, and you need to determine which option is which statement is illegal in C++. 30 seconds left. The quiz is finished, and if you use answer paper, please submit the answer paper to me. And let's see the answer. For the first question, the correct answer is option 4. Option 4 is the answer. Let's see this question. You have 2 ways to compute the answer. First, you can compute the binary representation of 6. The binary representation is 110 because you can use division to divide this 6 by 2. And you will find 6 equals 4 plus 2. And so you can find 110 is the binary representation of 6. Then if we perform left shift by 2, then this means we add 2 zeros. So 110 becomes 11000. And if you are not familiar with binary representation, you can see the reference web page, and you will find under C++ basics, you will find binary and decimal. Here is a tutorial, and you will know how to obtain the binary representation. Another way is to directly compute this value. If you still remember, this expression is equivalent to 6 times 4, so the result is 24, and you can obtain the binary representation of 24. 24 is 16 plus 8. So 16 plus 8, you can quickly find a binary representation is this one. Next, let's see the second question. The answer is the option 4. The answer is option 4. For this data type, unsigned integer 8, we need to know its size range. We know its range is between 0 and 255. Because A bits corresponds to the number of possible combinations is 2 to the power of 8, which is 256. And because it is unsigned, so its value is non-negative, and we begin from 0. So we know the size range of this data type is 255. In the second statement, you observe that the value of pixel is 257. So it is above the size range. So this will cause the problem, the issue of overflow. Because this value is over its range. Then what will happen if overflow occurs? And the value will return. So, for example, the value is 256. Then we will start from its minimal value 0. So 256 becomes 0, and 257 will becomes 1. So the value, the answer of this question is 1. Actually, you can use the modular operator to obtain the value. You can use you can also use the modular operator to obtain the value. The value is also 1. Let's see the final question. We need to determine which which statement is illegal? The answer is the option 4. Option 4 is illegal. So the first one will print a new line. The second one is not a new line, but this is legal. This will print a backslash and then print the character n. So second statement is legal. The third one is also legal. It prints nothing because inside the double quote is nothing. This is also legal. Option 4 is illegal because first, double backslash will output a backslash character, and the second one, backslash double quote. This is an escape sequence. This will print a double quote. However, the compiler cannot find the terminating double quote because double quote needs to be a pair. So we only have a beginning double quote, but we do not have the terminating double quote. So this will lead to a syntax error. Any question about a quiz? If no questions about a quiz, then we will return to our slides. Next, let's talk about typecasting. When you want to perform integer division, but if the numerator and denominator are both integers, then what will you do? Here, numerator and denominator are both variables, and they are not constants. So you cannot add 0.0 because for constants you can add decimal point to convert from integer to floating point. But for variables, you cannot use this. You cannot use this trick to convert integer to floating point. To do this, we need to perform typecasting. We need to cast the data type of the numerator or the denominator. And we have two ways. You can use the C style typecasting, or you can use the C++ style typecasting. You can cast the data type of the numerator from integer to double. This is the C style. You can add a parenthesis, and inside the parenthesis is the data type you want to convert. And if you choose the C++ style, the syntax is a bit complex. You need to use a keyword static cast, and followed by angle brackets. And inside the angle brackets is the data type you want to convert. And you still need to type parentheses. You need to use parentheses to enclose the variable you want to convert the data type. So you can see the C++ style is more complex. But C++ style has some advantages. It is easy to search because you can search the keyword static cast, so you can find where you perform typecasting. But for C style, it is difficult to find where you perform typecasting. Another difference is that C++ style casting can be checked by compilers, while C styles are not. What does this mean? Then we need to understand compile time and the runtime. Here I updated the slides of our first PDF. I updated one slides in this PDF. So this slide is about compile time and runtime. Here, compile time means the phase during the source code is converted to executable code. So this is known as compile time. While the runtime means the phase when the executable code to produce the program output. So we see that we have two phases. The first phase is compile time, and the second phase is runtime. And for this, this means C++ will be checked during compile time. So C++ style typecasting will be checked during compile time, while the C style typecasting cannot be checked during compile time. C style typecasting is checked during runtime. Later we will talk more about this. So time is up. Let's take a break for 10 minutes.
喂，哦，各位注意一下，我要去拿那个微积分课本，我要先问一下你们在不在？1号在吗？4号，4号，OK，22号好，23，30号，33，黄文显在吗？34号刘佳宇在吗？36号，44号，44号，46号在吗？46，那47号在吗？所以现在只有4个人在。好。
Hello, let's continue our class. We talk about compile time and runtime, and I will give you some examples about uh, compile time error and runtime error. So suppose an error occurs during compile time, then this is known as compile time error. For example, you forgot to type a semicolon, and when you compile your program, the compiler will show some error message. And since this error occurs during the compile phase, so this error is compile time error. Then I will show another type of error, runtime error. Here is the program. Suppose you perform division. However, the denominator is 0, and you will know this will cause the value to be infinity. But when you compile this program, the compiler the compiler did not show error message. It only gives you warning. So this is not error. This is only warning. But when you run this program, the program cannot finish normally because the exit code is a non-zero value. So if the exit code is a non-zero value, this means the program cannot finish properly. So this program has a runtime error because it cannot finish properly. So if you run this program can finish with exit code 0. When you see exit code 0, this means your program can reach the return 0. So if your program can execute this statement, then the exit code is 0. However, if your program cannot reach this line, its exit code will be non-zero. So for this program, we have runtime error. So do you know which error is more serious? Compile time error or runtime error? Which is more serious to the user? If you think compile time error is more serious, please raise your hand. Okay, if you think runtime error is more serious, please raise your hand. Runtime. Oh, okay. The answer is runtime error is more serious because if compile time error occurs, you can immediately find the mistake. The compiler will find a mistake for you. So the user of your program. Suppose you write an app in the App Store. Your user will not see this issue because your program cannot be compiled. So your user will not see the compile error. Only the programmer will see the compile error. But for runtime error, this means your code, your program can pass the compile phase. Then when the user of your program run your code, they encounter some issues. So this is more serious because the user's operating system or might corrupted. So the operating system might be damaged. So the runtime error is more dangerous. So let's return to this point. So C++ style cast can be checked by compilers. This means C++ style only leads to compile time error. If we have some errors, and C style casting cannot be checked by compiler. So C style casting, if it has some issues, then we will have runtime error. So for safety issues, if you care about safety issues about your program, you should use C++ style typecasting. Next, we will talk about the increment and the decrement operators. Here, the double plus is the operator. This is the increment operator, and this will add 1 to the value of a variable. So this expression is equivalent to, so n plus plus is equivalent to you add the value of n by 1, and you can write n plus plus or plus plus n. The two are the same. For this example, you can write n plus plus or plus plus n. And similarly, we have the decrement operator, the double minus operator performs subtraction by 1 from the variable. So n minus minus is equivalent to you subtract 1 from the variable. So you can also write minus minus n. And actually, the name of C++ programming language originates from this operator. So this operator means plus 1. So C plus 1 means C++ originates from the C programming language, and adds with some additional syntax support for the object-oriented programming. But when you want to use this operator with other operations, we need to pay attention. So for example, you want to mix the use of increment and the multiplication, then you need to pay attention to post or pre-increment. Post increment means you write n plus plus. So plus plus is after the variable, and pre-increment means you place plus plus before the variable. This will lead to different results if you apply this operation with other mathematical operations. And let's see this example. initially we declare a variable n, and we assign 2 as its initial value, and so let's see this example. First, we declare n and assign some initial value. Then you declare m. You can also combine declaration with assignment, so you can combine the line into one statement. But for clarity, I choose to separate declaration from assignment. Then in this statement, we have 2 operators. In fact, we have 3 operators: assignment, and multiplication, and this plus plus. We have 3 operators. Then you need to determine which operator will be carried out first. So we have 3 operators, and we need to check the precedence table. So you can search C++ precedence, and then you can find this table. You will find plus plus. You will find increment and the decrement in upper position. Upper position means higher precedence. So plus plus has a higher precedence. And then the multiplication. So multiplication is here. Its priority is priority is 5. And then assignment is very low. Assignment is here. Its priority is 16. So for this example, we know plus plus will be carried out first, and then the multiplication, and then the assignment. But for this, we have 2 possibilities. Here, either 3 times 2 or 3 times 3. So you need to determine this addition will be performed before or after the multiplication. So we have two possibilities. The first one is you perform addition first, and then you perform multiplication. This is the first possibility, and the second one is so we have the second possibility. We perform multiplication first, and after multiplication we perform increment. So which one? So for this expression, it's case 1 or case 2. Because if you switch the sequence, the execution sequence, the outputs will be different. for this one, this is known as this is post. This is post is increment. Because the plus is after n, so this is post increment. For post increment, this means the addition will be performed first, and then the increment will be performed after the multiplication. So for this case, the result so this statement corresponds to case 2. So its value is, so m is so m is 3 times 2, so m is 6. M is 6. So we see that so for this statement, the value of m is 6, because post increment corresponds to case 2. However, if you change the position of plus, if you use plus n, then this becomes pre-increment, because plus is before n. Then this statement will correspond to case 1. This means the addition, the increment will be carried out first. So n is increment, it is added by 1 first, and then we perform the multiplication. So for this for case 1, we know the value of m is 3 times 3. So the value of m is 9. So you see that if we will use pre-increment, the value of m is 9, and this is different from post-increment. And here is the recommendation. The recommendation is do not use post or increment in your code. If you want to mix this operator with other operators, so do not use this, because this can lower the readability of your program. You can write program like this. For example, if suppose you want to perform pre-increment, then your code you can separate addition from multiplication. So you can write these 2 statements instead of the single statements, because the 2 statements is more is more clear. Your code is clean. So pre-increment or post-increment can be confusing, because you need to think about which operation will be carried out first. This can be confusing. But when you write code, like when you write clean code, there will be no confusion. You clearly know addition will be performed first and followed by multiplication. So for the clarity of your code, I always suggest use do not mix the use of pre-increment and post-increment with other operators. However, if there is only single operation, if only addition in a statement, you can use this operator. This is very common, especially when we use for loops. We typically write n++. Next, let's talk about comments. In C++, we have two styles of comments. The first one is a single line. This is the double slash operator. If you begin with the double slash operator, then the compiler will remove any characters after the double slash operator. So this you can write comments. You can write comments after the double slash operator. The compiler will ignore these words. And the second style is multiple lines. This is from the C programming language. You can begin with the slash followed by a star. This is also the another operator. This will begin multiple lines for comments. And if you want to terminate the comment, you need to use star followed by slash to terminate these multiple lines comments. For example, so I usually use single line comments, and you will notice the color is different because this is due to the syntax highlight of the IDE. Your IDE usually will use syntax highlight to let you know what is a comment. And in some textbooks are suggested to write comments for each statement like this. For example, I know some textbook will teach you to write comments for each line, but this is not necessary. For example, you write A is the number of apples. And clearly, this is redundant because you can choose the name of the variable to be apples. So you don't need to write comments like this. You can choose meaningful variable names. Similarly, you don't need to write B is the number of bananas. You can choose the variable name to be bananas. And so the reader of your program can understand your code. What is the intention of your code? So this is example between bad code and clean code. In clean code, the reader can understand your intention without comments. So the best way is to express your intention with variable names or function names. Later we will learn how to define a function. This is also very important if you want to write clean code. Another reason not to write the redundant comments is if you are a programmer, you need to maintain your code. You also need to maintain your comments if you write comments. Because if you update your code, you also need to update your comments. So this will increase your workload. Next, we will go to the third part, which is about console input and output. we already use this. We already use this. We already use cout. Cout means console output. We use this object to print some messages in the console. So we already use cout, and cout is usually followed by this is the left shift operator, and we print this string. And actually, this string is directed to the console output. You see this direction; it is from right to left. So we would direct this constant to the console output, and therefore the console output prints hello world, prints this string. And this object is defined in the IO string library. So if you want to use this object, you need to include this library. If you choose to omit, you will see some error message, because this object is not declared in this scope. Another object defined, this is for output. If you want to input some value, you can use cin. This is also an object defined in IO string library. Next, I will give some example about how to use cin. And this is C arrow. If you want to print some error message, you can use C arrow. Or you can use cout. Both can be used to print your error message. For cout, you can use multiple left shift, so you can output many strings or variables. And if you want to print new line, you can use \n, the escape sequence, or you can use the endl variable. Endl is also defined in IO string. This is the same as the \n. This slide is about namespace. This is a quick introduction. Actually, we have a chapter. We have a chapter about namespace. You can see the contents. You can see the contents of the textbook. The textbook has a chapter about namespace. Here. Chapter 11. This chapter is about a comprehensive introduction of namespaces. Namespace will be used when you want to collaborate with others, because for a large project, we usually need many people to collaborate. And if you want to merge all the people's code, you need to avoid the variable names to be the same when they are in the same scope. Because in the same scope, we can only have one unique variable name. So the variable name cannot be used repeatedly in the same scope. For example, programmer A use variable name size, and programmer B also use variable name size. When we compile the code, this will cause conflicts. And to solve this issue, we need to use namespace. You can each programmer can use his own namespace, and this can avoid the conflicts of variable names. But if you want to know more, you can read this chapter by yourself. I will only provide a quick introduction, so I will not teach every details in this chapter. So return to this example. If you do not use this line, if you do not use using namespace std, if you delete this line, then when you compile the code, you will find error message. It says CL was not declared in this scope. And you might be confusing because you think CL is defined in IO string, while the compiler say CL was not declared. Because actually the full name of this variable is std double column CL. So actually the full name is std double column. So end L is the same. The full name of end L is std double column. So you need to type the full name of this object if you want to use it. But this is very tedious because your program might have many CL, Cin, and L. You don't want to type many std double column, so you can use this line. You can use the two lines, or you can use this line. You can use this using std cin or cout. Then you can omit the std prefix. You see, now you can omit the std prefix for cout. And similarly, if you want to omit the std prefix, then here you need to add one line. But this is very tedious because you need to add all the objects in the IO string. So this is very tedious. So if you want to if you want to consider all the objects defined in the IO string, you can use using namespace std. Then this line will prefix all the objects by std double column. So in this way, you don't need to type std double column before every variable. Next is about string. Later we will cover the string data type with more details in later chapters. So we will cover string, C string or C++ string in later chapters. And you can take a look of this slide by yourself. The next slide is about formatting outputs. Suppose you want to print a floating point, and the default output is like this. You will see many digits after the decimal point. Sometimes you want to control the number of digits after the decimal point. Then you can use the following statements to control the precision. So in this example, if you set precision to be 2, then the program will output 78.05. So you can use this function code to set the precision of the floating point. Next, I will demonstrate how to use cin. Cin is to read user inputs, and I think some already use cin if you start writing assignment 1. In assignment 1, we already use cin in the code template. So we use cin to read user inputs, and the user input is saved in the slice variable. And we can pay attention to the operator after cin. This is the right shift operator. You know the direction of this operator is different from the left shift operator. So this means the user input is directed to the variables slice. So you know the direction of this symbol. We direct the user inputs to variables. I will demonstrate how to use cin. You can copy this example. So if you copy the code, you also need to declare some variables, because here we use a variable dog name, and its data type is string. So you need to declare this variable, because C++ requires you to declare variable before using it. And this data type is not built in C++. You need to include a library to use this data type. Now we can start to compile and run. So first, the program will output a string. What is your dog's name? Then we will proceed to the cin statement. This will let you to enter some characters. So you can type any characters. So for example, I type puppy. Then when you press enter, the puppy will be saved in the dog name variable. Then this statement is finished. Then proceed to the next statement. the program prints hi, and the program prints the value of dog name. So the value of dog name is puppy. So the program will print hi puppy. Some students switch the sequence. For example, some students switch C in and C out, and this will result different program outputs. You see that if you switch the sequence, then these strings will not be printed because now we have C in the first line, so you see no messages. Then after you type some words, you can see the second you can see the C out. So if you switch the sequence, the program outputs will be different. Another feature of Cin is that Cin will not read space or read line break. So if you type space or you type line break, these characters will be ignored by Cin. So let's try some examples. Now I run this code again. I type ABC space DEF, and let's see the outputs. You will notice that the dog I enter ABC space DEF, and only ABC is stored in dog's name, and the contents after space is ignored because this space. So Cin will read ABC as the first input, and the space is a separator. So DEF is the second input, and the first input will be stored in dog name. And because we don't have second variable, so the second input will be skipped. So we only see the first input. So the first dog name is ABC. And actually, you can declare more variables. For example, you can declare more variables, and you can input two names. So here I also, and you see that if I type ABC space DEF, ABC is the first input, DEF is the second input, and the first input is stored in dog's name. The second input is stored in cat name. So here space or line break is a separator. So and then later we will cover more details about Cin. If you want to read spaces, or if you want to read line breaks, you can use some function calls. And we have finished this chapter, and let's proceed to the next chapter. Next chapter is about flow control. And let's see the slides. First, we will learn Boolean expressions, and then we will learn branching mechanisms, including if-else and switch statements. Branching means you will have some control statements to determine which block you want to execute. Then you can use the branching mechanisms. We will also introduce the loop. This is also very common. We use if you want to repeatedly execute some operations, we will use the loop statement. Boolean expression is fundamental because it will be used in if-else and in the for loop or while loop. So Boolean expression is a fundamental expression. Let's revisit what is an expression. Expression means any operations that can generate a value. If the value is limited to Boolean variable, then this expression is called a Boolean expression. So the value of a Boolean expression is either true or false. And typically we use comparison. We use comparison operators to generate Boolean expressions. Another one is logical operators. So we either use comparison or you can concatenate comparison with logical operators to form Boolean expressions. And these expressions will be used in if-else, for, and while statements. So we can start from some examples. Suppose we perform some comparison, or we perform some, then you save the, because this is a Boolean expression, so its result is a Boolean variable, and you can save the result to a Boolean variable. So first you can declare a Boolean variable, and then you can assign the value of Boolean expression to this variable. So this should be true because 2 is less than 3, so this is true. And if you print the value, it will shows 1, because in C++, true is 1, integer 1. If you modify, you change the operator greater than, so this should be false, because 2 is not greater than 3, so result should be false, and false is 0 in C++. You can also change another comparison. For example, this is the equality operator, so this should be false. This should be false. You can also use not equal, so this is the not equal operator, and this should be true because 2 is not equal to 3. I think we can take a break for 10 minutes. Hello. Let's continue our class. Uh, uh, I will show how to use the Boolean expressions. Uh, Previously, I show we can use comparison operators to generate Boolean expressions. Sometimes we want to combine. You want to for example, you want to make sure whether x is less than 5 and x is larger than 1. Sometimes suppose you want to combine two conditions, then you will need to use a logical AND. For logical AND in C++, we use the double ampersand operator. So this is an operator in C++, and known as logical AND. So here you can use logical operators to combine two Boolean expressions. Or sometimes you want to use OR. For example, you want to combine whether x is smaller than 5 and y is greater than 1. You can if you want to use OR, and OR this is double pipe or double vertical bar. You can use this operator to combine two conditions. So next, let's see what is the logical AND. So logical AND is a binary operator. This means this operator has two inputs. So this operator, for example, this operator has two inputs. The left-hand side is the first input, expression 1, and right-hand side is expression 2. So this operator has two inputs, expression 1 and expression 2. And the expression 1 is Boolean, so its value is either true or false. This is similar to expression 2. And we can list all the combinations. So we will have 4 combinations. And the third column is the output of this operator. We see that if any of the input is false, then the logical AND will output false. So if any of the input is false, then the logical AND will output false. Only when both inputs are true, logical AND will return true. So this is the logical AND operator. The next operator is the OR. So OR is also a binary operator. So this operator has 2 inputs, expression 1 and expression 2. And this operator will return true if either one of the input is true. So if either one of the input is true, then logical OR will return true. And only both inputs are false, the lower operator will return false. So you can you can try examples. You can true, so false. So true or we use AND first. So true and false is false because either one is false. So the result is false. So result is false, and you can change it to another value. You can try. You can perform many experiments by yourself, and you can also change to the OR operator. So if this operator is OR, then result is true, because if either input is true, result is true. So if we run this program, result is true. And we also have the third logical operator. This operator is different from the previous two. It's unary. Unary means this operator has a single input. So this operator has a single input. It's either true or false. And its output is the inverted result. So its output is invert the input. So now you can add the NOT operator here. Originally it's true, and after inversion it becomes false. So if you add the NOT, logical NOT, this will become 0. So this is the logical NOT operator. Next, let's talk about precedence of operators. And if you have multiple operators in the same expression, and you need to determine determine which operation will be carried out first. Below is the precedence table, and upper position means higher precedence, and lower position means low precedence. So assignment is the lowest, and logical NOT is highest, and followed by multiplication, division, and addition, subtraction. And then this is the comparison operator, and followed by logical operator. And you will notice that we have two similar operators. So you know that here is the minus, and we also has minus here. And do you know why? What's the difference between the two symbols? The precedence is different. The first one, unary minus, has higher precedence than this subtraction. So the symbol are the same. You use the same symbol, the same minus symbol. Actually, you can see from its name. This is unary. Unary means single input. So if this operator has only one input, then this operator is unary minus, like this one. This operator minus only has one input, so this is unary minus. And the subtraction is binary. It requires two inputs. So you can determine which operator from the number of inputs. Actually, you can So when you write an expression like this, 3 minus 1. Hey, sorry, it's sorry, this. Oh, yeah. So for this example, if you write 3 minus 1, when you write expression like this, you use 2 minus, and which operation will be carried out first? In fact, in this time we have 3 operators. We have assignment. We have 2 minus, and actually this one will be carried out first. So because this is unary minus, so according to the precedence table, unary minus has higher precedence. So here -1 will be evaluated first, and then second by the subtraction. Then we have this is binary operator. We have 2 inputs. We have 3 and the -1 as its input. So you perform 3 minus -1, and then we obtain 4. So this operation is equivalent to 3 minus -1. And actually you don't need to add parentheses, because unary minus has higher precedence. So you don't need to type the parentheses. So this statement is equivalent to the next one. So unary minus will be evaluated first, and the second is the addition, and then followed by comparison, and then finally the logical OR. So actually you don't need to type the parentheses. If you want, if you perform this line, you don't need to type any parentheses. The next one is the next one is a mistake, a common mistake about using the NOT, logical NOT. Suppose you want to write, you want to compare time with limit, and after that you want to perform the logical NOT to invert the comparison. And in this case, the parenthesis is necessary. In this case, parenthesis is necessary. You cannot remove the parenthesis. If you remove the parenthesis, then this expression becomes this one. And this one will generate outputs different from our expectation. And because this expression means we perform logical NOT to time. if you perform a logical NOT to time, then this means this value is either 0 or 1. Because logical NOT generates is a Boolean expression. Its value is either true or false. So this expression becomes either 0 or greater than limit, or 1 greater than limit. And this is not what we want, because we want to perform. We want to invert time is greater than limit, and we do not want 0 is greater than limit or 1 is greater than limit. And you can actually verify this by perform some experiments. So for this example, time is 10, limit is 20, so comparison generates true. And if you use logical NOT, this will become false, so result is 0. And if you omit the parentheses, then this becomes either 0 is smaller than limit, or 1 is smaller than limit. And you see, this is not how you want, because we don't want to compare limit with 0 or limit with 1. We want to compare limit with time. So this is not what we want. And in fact, for this expression, time, if you perform logical NOT to time, this will generate 0. Non-zero value is true, so time is true. And if you invert true, this will be false. So this is 0. So this is 0. And 0 is smaller than 20, so this will generate true. So result is 1. So for this example, result is 1. Therefore, if you want to use the NOT operator with the other comparison, you remember to add the parentheses. And the final recommendation is that you can almost always avoid to use the NOT, logical NOT, because logical NOT needs you to think twice. You need to think. We perform comparison, and then followed by logical NOT. So you need to think twice. However, you can rewrite this expression. You can modify greater than to smaller or equal to operator. So this one is better to understand. It's easy to understand. So this means you can always avoid using logical NOT This can enhance the readability of your program. The next slide is another common mistakes when you want to when you want to use a strings of inequalities. For for mathematics, we usually write x smaller than y smaller than z. So in mathematics, if we write this expression, then this usually means we want to perform x is smaller than y, and y is smaller than z. So this is what we mean when we write this expression in mathematics. However, you cannot directly write this expression in C++, because here I will show some examples. So I change to so let's see this example. Suppose I declare 3 variables x, y, z, and I set initial values to these variables. Then we perform this expression: x is smaller than y, smaller than z. And you can try to compute the result of this expression. For mathematics, this should be false for mathematics, because 5 is not smaller than y. 5 is not smaller than 4. So for mathematics, this should be false. Oh, so this is a typo. However, you notice the C++ outputs true. So this means the value of this expression is true, not false. So this is different from what we expect in mathematics. So actually, we can decompose this expression. This means we compute x minus y first. We perform the comparison first, and this value is either true or false. So its value is either 0 or 1. Then we compare 0 with z, or we compare 1 with z. And for this example, x is 5, y is 4, so this is 0. So the Boolean value of this comparison is false, and false is 0. And then we compute 0 is smaller than z. Since z is 3, so this will generate true. So the value of result is true.
So you see that this is different from what we expect, because we expect x is smaller than y and y is smaller than z. However, if you write this expression means either 0 is smaller than z or 1 is smaller than z. So this is not what we want. So the correct way to express this expression in C++ is you need to use logical AND. So the correct way is to use logical AND. So now the result should be false, because xy is false. First comparison is false. The second comparison is also false. So this slides reminds you when you want to perform inequalities like this, then you need to use the logical AND operator. Below you can omit the parentheses because smaller len has higher precedence than logical AND. The next slide is about a trick known as short circuit evaluation. This is for the logical AND. I will skip this one because this is not very important. So I just skip this one. The next slide is about enumeration. This is like a data type. You can use this data type to declare constants. And I will also skip these slides because this is a bit more advanced. So I also skip this slide. And this will not be included in the exam scope. So you can skip this slide. The next topic is about the branching mechanism. Let's see the if-else. This is the most common statements in programming language. The if-else statements. If and the else are keywords in C++. And after the if keyword is followed by a pair of parentheses. And inside the parentheses is a Boolean expression. So we will perform some comparison or logical operator inside this parentheses. And this value is either true or false. Because Boolean expression, the value of a Boolean expression is either true or false. And if Boolean expression is true, then the yes statements is under if yes statement will be executed. And if Boolean expression is false, then the statement under false, the no statement will be executed. So the if else statement enables you to choose between two statements. You can choose this statement or this statement depending on your condition. So you can use this condition to decide which statements you want to carry out. And actually, we can have multiple statements inside if or inside else. If you want to use multiple statements, then this is called compound statements. We usually add a pair of braces. If you add a pair of braces, then this is called a compound statement. And inside the braces, you can use as many statements as you want. Empty is also fine. Inside the braces, you can be empty, or you can use multiple statements. So below is one example. I will show you how to use the if-else statement. So here is one simple example. So if the value of x is smaller than threshold, it's a constant, it's a naming constant. So I use uppercase. If x is smaller than this value, then the program will print yes. Otherwise, print no. So since x is smaller than threshold, so the program will print yes. If you can lower the threshold, if you lower the threshold to 2, then this condition is not satisfied because the Boolean expression is false. So the else statement will be executed. So this is the typical usage of the if-else statement. If you want to add multiple statements, then you need to add a pair of braces. So we recommend you always add a pair of braces after if and after else. Because when you want to add more statements, this is more convenient, and you can add multiple operations inside this block. For example, you might perform some computations inside this block, and later we will see more examples. And this slide tells you can omit else. So else is not necessary. You can use if statement without the else part. Another one is a common mistake when you use the if statement. For example, you want to compare x to 12. You want to test whether x is equal to 12. And we should use the double equals. This means equality operator. This is in the comparison operator. Here, this is the equality operator. However, if you if you made a typo, you forgot to type, you only type one equal symbol, then this becomes assignment. So this becomes assignment, and this will generate this might generate a different result. So let's see this example. So for this example, we test whether x is equal to threshold. If equality holds, then program prints yes, otherwise prints no. And obviously, 5 is not equal to threshold, so program will print no. However, if you made a typo, so suppose you only type one equal symbol, and then program outputs will be different. This time program outputs yes. So what happened if you write expression like this? When you write expression like this, this is assignment, and the assignment is an operation. It will generate a value, and this value is the value of the right hand side. So the value is 3. So actually, this is equivalent to if 3. And next, you wonder, inside the parentheses should be a Boolean expression, but we have an integer. So this is not, so you already know if 1 is true, and you already know if 0 is false. However, here we have integer 3. So for this case, 3 is true or false. So anyone know the rules? If the inside the parenthesis is an integer, then this integer is true or false. We know integer 1 is true and integer 0 is false. However, if the integer is 3, it is true or false. Clearly, it is true because the program prints yes. So 3 is true. In fact, we have a rule. The C++ committed define a rule for this integer. You can here I cite this rule in the reference web page, and you can find under flow of control, and you can find this one. The rule is here. All non-zero values will be converted to true, and only the 0 values to false. So this is the rule for C++ to convert integers to true or false. So now we can yeah. So you can you can try this by yourself. If you type 5, this should be true because this is non-zero. So this is true. You print yes, and if you type 0, this is false. If you type -1, so the program will print yes or no. If inside the parentheses is -1. If you think the answer is yes, please raise your hand. If you think the program will print yes, please raise your hand. Oh, okay. If you think program will print no, please raise your hand. Nobody? Oh, okay. The program prints yes. Because according to this rule, negative is non-zero, so negative is non-zero, so negative will be converted to true. So -1 is true. So in this case, the program prints yes. So now you know how to determine the value of integer is true or false. And actually, if you write actually we seldom perform assignment inside the parentheses. We wouldn't do this because you would not do assignment inside the parentheses of the if statement, because if statement is for branching mechanism, not for assignment. So we seldom do this. So usually this is, if you see the code like this is usually a typo, and some compiler will give you warnings. Here, if you choose another compiler, here is another compiler, and you can turn on the compiler option. You can turn on the compiler option to generate warnings for your code. So here, I turn on the compiler option. You can choose turn on the warnings, and you can see some compiler outputs. The compiler gives you some warnings. In line 7, it says you use an assignment as a condition. So here, because we seldom do this, so the compiler suggests you to use equality operator to perform equality comparison. So here, warning, one warning is generated. So here you can say a cross, a red cross here. But this is only a warning, not error. So the compiler, you can see the execution result. The result prints yes, because this is legal. This is legal syntax in C++. And the textbook suggests you can change the you can switch x and with the constant. You can switch the two because if you place 12 on the left hand side, and this time you cannot perform assignment because the left hand side must be L value. L value means the left hand side must be a variable, cannot be a constant. So if you place the constant on the left hand side, then you cannot perform assignment. And this time you can switch this. So you can, if you switch x with threshold, then this time this will generate a compiler error. You see here is the error message. So you cannot, I directly write 3. Because you cannot assign the value to a constant. The left hand side must be a variable. So he says the expression is not assignable because the left hand side is not a variable. So you cannot see. So I think the lesson has come to an end, and the class can dismiss now.